Hey everyone, this is part 1 of Uniswap V2 deep diving course. In this video, we will be going to learn the introduction to automated market maker. And before actually deep diving into the introduction to AMMs, we will be learning the how order book exchanges work. You might have seen order books in most of the traditional exchanges and centralized crypto exchanges. So you might be familiar with the interface of order book exchanges where you can see these are the buy orders and these are the sell orders, basically bid and ask orders. Here you can see the current price is 3409.46. This actually means that the last order which actually matched is of the price 3409.46. So basically when bid order meets the same as ask order, then the price gets matched, order gets fulfilled, and the current price will get updated. Trader always want to buy low and sell high, so the execution price met in the middle. So this is the high level overview of how order book exchanges work and how prices actually gets determined in order book exchanges. Now let's come to automated market maker. You might have seen the UI of Uniswap V2 or some other automated market makers. You have seen in one pool there are two tokens. So basically in this interface you can see if you provide some ETH you will get some DAI. So there is the pool of two tokens which is ETH and DAI. There might be a pool with more tokens in some different protocols like Balancer. We will discuss that in our upcoming videos. So now you can see here we will provide some ether. So here we are providing 0.005 ETH and we are getting 1 DAI in exchange. So this actually works on certain algorithm. Also price is gets determined by some algorithm. What is that algorithm? That is the constant product market maker, which you might have heard the X into Y equals K. We will now take a basic example to see how actually trade happens in automated market maker. So here is the simple, we will take the simple example of USDC ETH pool. So we have USDC ETH pool. Let's say the quantity of USDC in a pool is X and the amount of ETH in the pool is Y. So what constant product market maker tells is that X into Y should remain constant. The K is invariant here. So the amount of USDC and the amount of ETH, their product should remain constant even after the trade. So here we take example. So we have deposit dy amount of ETH. So in this pool, we have deposited the dy amount of ETH. As we have deposited ETH, we will get some USDC in return. So let's assume that we got dx amount of USDC in return. So now what's the condition after the trade of pool? So after the trade, the x will be changed to x minus dx because we got some amount of USDT when we deposited some ETH, and as we deposited the dy amount of ETH, the pool will get updated to y plus dy. So this is the scenario after the trade. Also, we define the liquidity parameter L here. So what is the liquidity parameter? So whenever in Uniswap V2 or any other AMM, you see the liquidity parameter L is actually equals to the under root of product of quantities of two tokens in that pool. So in code also, in Uniswap code also, whenever you see the liquidity, current liquidity or anything, it just means that it's the square root of product of two tokens or the quantity of two tokens. Let's now derive the formula. Let's say we have deposit some amount of ETH, how much amount of USDC we will get. So we will derive the formula for it. So the condition is that the invariant should not change before and after the trade. So here you can see the xy equal to k. This is, let's say this is the before the trade. Suppose that a trader wants to buy an amount of dx of token A. To do so, they must deposit an amount dy of token B. So we deposited the dy amount of token B. We have two token A and B, like we have to take to the example of ETH and USDC. In the same way, we have A and B. We deposited sub tokens amount of B, which is dy. So before the trade, there is x into y equal to L square. After the trade, the L square should remain constant. L square should not get changed. So here also the L square is equal to xy. So in this equation, we put xy instead of L square. Now we will derive this equation. So here this L square is equal to x into y. So we put x into y here. Now dividing both sides by x minus dx, we will get y plus dy is equal to x into y divided by x minus dx. Now solving this equation further for dy, we get this here, this xy and yx will get cancelled. And finally we get the dy, which is the y into dx divided by x minus dx. So basically we need to deposit this much amount of token B to get dx amount of token A. In a similar way, we can calculate the dx. Now let's take a very simple example to see how practically we calculate all of this. Let's say we have USDC ETH pool in which amount of USDC is 100 and amount of ETH is 10. So we are considering the amount of USDT in X direction because we have to represent it in graph, and amount of ETH in Y. So we have coordinates first. This is the initial coordinates. So this is the initial position of the pool, 100 to 10. Let's say we will take the two scenarios here. First scenario is, let's say we want to buy 50 USDC, and the second scenario is when we want to buy 90 USDC. So when we calculate the dy for 50 USDC, we will get 10. It means that to buy 50 USDC, we need to deposit 10 ETH in the pool. So the effective price we paid actually for 1 USDC, we will divide this 10 by 50, we will get 0.2 ETH. So the effective price we actually paid in this trade for 1 USDC is 0.2 ETH. Also, when we buy 50 USDC, the 50 now after the trade, the USDC, only 50 USDC will be remaining in the pool, and the amount of ETH will get increased to 20. Also, let's take the second scenario. Let's say we want to buy 90 USDC. If we calculate the amount of ETH we need to deposit to buy 90 USDC, it will be 90 ETH. So we need to deposit 90 ETH to get 90 USDC. So what is the effective price that we paid for to buy 1 USDC? It's actually 1 ETH, 90 divided by 90. So it's actually the 500% increment. So why this first of all happened? So this happened because of slippage or price impact. We will be discussing about the slippage, price impact, spot price, effective price in our upcoming videos. But now in short, just remember that uh, actually there is some slippage when you actually buy with the large quantities. Now what we will do is we will represent this coordinate graphically. So what will be the situation of pool after buying the 90 USDC? So when we buy 90 USDC, the pool, only the 10 USDC will be remaining in the pool, and so the amount of ETH will be 100. So this is the situation of pool when we buy 50 USDC and we buy 90 USDC. Also this dy we calculated on the basis of the formula that we have derived here. It's y dx divided by x minus dx. So y is basically the 10 here, dx is the 50, we want to buy 50 USDC, so dx will be 50, and in denominator we have x minus dx, so x is 100 minus dx is 50. That's how we calculated all of this. Now coming to the graphical representation, we have A, B and C point here that we plotted on a graph. So this is the initial position here, which is the having coordinate the 110. B is when we buy 50 USDC. This is the situation of pool after we buy 50 USDC. And C is the situation of pool when we buy 90 USDC. You can see the clear difference between the slopes of line AB and AC. And if you actually calculate the slope of line AB and AC using the 2-point form, so we have the 2 points A and B. So using 2-point form, you can calculate the slope of the line, which will be 10 divided by 50, which is the 0.2, and the slope of AC will be 1. So you can see that the slope is actually equal to the effective price we paid for 1 USDC. And you can see clearly the price impact using the graphical representation. We will see this in depth in our further videos. So this is the overall introduction to automated market maker. The next video we will see what is spot price, what is effective price, what is price impact, and we will derive the formula for price impact or slippage.